Hello, welcome back to another repair odyssey. Today we have a MacBook Pro 2017. The issue with this is we only got 5 volts on the charger, so it won't charge and it won't turn on. We already measured the mux chips, so the 4, one here, 1, 2, and the 4th one, which all have the right output or input of power, so there is no short or any issues. Well, I think it is so. If you want to know more about these chips, as you know, if one is defective, then it's possibly that all of the 4, in this case we have 4 ports, won't work. So head out to LogiWiki, Google for or search for what it's called, CD3215. Then you see all the power lines and all the volts you need around. Capacitors you can measure to see if they are okay. Yeah. So board. Pretty hidden on this board. This is the board number. Oh, here it is. A20-00-281. Yeah. So now we decided to take a look at. Let's plug in the power again, just to confirm that. Still no success. We have 5 volts on the charger and no amps. Okay, next step here is to check. Let's do this together. If we have our beloved GT not present, which is created from that ISL, I believe. Yeah. Okay. Quick look under the microscope. This is our ISL chip, which is, so PPV in goes in, which is on, let's see whether we can measure that. PPV in pin 5, which can be measured on the cap below. So V in should be present. Hope so. And we have a fault here. Okay. And the outcome should be just give me a second. What's wrong? Where am I? So ISL chip. Okay. Let's also measure this chip. And also here. Okay. Okay. Where is the enable? PM enable? 3v3 G3 hot is on pin 27, which we cannot measure. You have to go over a resistor, which is located here somewhere. Is it this tiny resistor? Yes, it is. Which is here. And there we have nothing. So it is not told to turn on. The question is why it is not told to turn on. So the next step would be anyway, if you're sure that the CD3215s are okay, to replace that ISL chip. What makes me a bit confused here is that PPV-in is 5 volts, which is a bit strange. So here we have a cap B on top, 4.9 volts. Well, schematic says 3.3 volts, while we have 5 volts. I don't know. Maybe we have to see where PPV-in is created. Where is it coming from? Oops. I'm lost. Sorry, give me a second. Okay, let's change the view. V in is on the input line. It should be near come on. Sensor. So can we check this? Okay, here we have a big cap. Let's measure this cap. It should be present. Should it? It's one of our CD3215s. Okay, big cap below. Oh, that's the line we're missing, so nothing here. Okay, I'm a bit confused. I need to go back. To U7000, which is that ISL. So we have PP from battery, which is not connected. PPB in. Let's search for this in the there it is, from USB-C source, charger, or PP bus G3 hot. Here we have a transistor, or well, two lines coming in. Let's go to D6902. Which is near here. Oh, did I just measure that without any power connected? Just give me a second. Quick check. Just a quick check. 0.04 volts. Not enough. So let's go back here. Now we measure that near this enable thingy. So this is opening and saying, okay, you can pass or you can pass. Neither one of you has to be present. Either it's the battery or the main power from USB-C. Which is present. Yeah. Yeah, okay. Nevertheless, this line is here. Not finish. Let's go back to the source. Well, that is our 5 volt, which we know which is present. The number 1, as you can see in the schematic, is V in. The other one is the charger, which is not present. Connected PPDC in, which is coming from nowhere. Charger, oh, I'm sorry. PP bus G3 hot rail be in. So okay, output, is this where the 3.3 volts is created, or is it just passing through? So PP bus G3 hot is the one that is missing. Maybe because it is not told to turn on. We're measuring that resistor next to that, which is also 5 volts. And I wonder why we have 5 volts here. This goes to the gate, okay. Yeah, nevertheless, a lot of talking, and so I've been, just to follow up, we've been that diode, or whatever you call it, D6902, which we have our 5 volts, and outputting 5 volts, strangely. Let's go over to that cool 5490. Where is it? Okay, nevertheless, what we're gonna do is we're going to change that ISO just to confirm that this is not the issue, because this is creating the main G3 hotline. Everything here looks okay. So ISO 9239. So we have top nozzles, some of those. Come on, get out. Let's have a look on the backside. It's always good to look on the backside to be sure that there is nothing that can be destroyed, just for caution. Here we are, a new chip. Let's see if this is solving our issue. Let's put it a little bit on the side that we do not blow it away. A little bit of flux. I'm going with 420 degrees. This is my Hotairstation, it can be different on yours. A bit more air, 60, 70. side. Over iron, a little bit brush, clean this over. The reason why I'm changing this is because we have a slightly blown battery, which also can be a good indicator why this chip failed. What a blob. Okay, yeah, that should do. It's not how it looks like in the Pros. Cut off. Just wait to move until you see it starts sucking, so we won't rip any pads. So this looks quite okay, not much to clean here. We do not have any dirt, do we? A little schmutz here, but yeah, I think we're good. Always keep your tools clean. So let's take the new ISO. Have a quick look on the back side. Is it clean? Yes, everything is clean except my tweezers. I forgot the direction. I think this is direction. I think this is. The right direction. Can we confirm that? P1. Yeah. Okay. Hope so. Not 100% sure here. So now I'm going down to 360, 380. Starting from the distance, not to blow the chip away. No. Okay, let's go a little bit more. A little bit more flux. Tounge, get in that direction. You're following. Okay. So in position. Sorry, but I have to stop the video. Let me see. This is really my position. I'm sure, but I'm not 100% sure, so I'll be back in a second.